2 of digital communication to study and generation and reception of BPSK and its perform its spectral analysis. Now the apparatus requires the trainer kit for digital PSK modulation and demodulation, again the CRO and connecting props. Okay, so now in the kit you can see there is the front panel of the PSK modulation demodulation. You can see there are two types of input in the modulating signal. These are the modulating signal. You can connect the desired 8-bit combination or alternate 1-0 combination using this clock generator. And second input is the carrier input, which is the sine wave generator, which is connected to the carrier input, and one of the input, either this or this, will be connected to the modulating input of the modulator. By using this offset button, you can control the amplitude of the modulated signal. That is, if you want to see separately the different bits, you can increase the value. If you do not want to see the difference between the different bits applied at the input, you can decrease it. Now we will make the connection, that is I am connecting clock generator to the this modulating input and carrier signal to the carrier input. Okay, so at the output, that is, it will be connected to the oscilloscope to see the output. Now it is the connection, that is the clock generator is connected to this modulating input, carrier is connected to the carrier input, okay, and the output is connected to the oscilloscope. By rotating this, okay, if I increase or if I increase this rotating button, you will see this, that is the difference between the, it is the alternate 0 1, so it is 0, we can see the clearly it is 0 for phase is 0, and for 1 phase is 180 degree. Okay, it is alternate 1 0. So if you rotate in anti-clockwise direction, you will see the closeness between the 1 and 0. Okay, it is lowest value of the knob, so you can see the different values for applied bits at the input of the demodulator. Okay, similarly you can perform demodulation, that is just connect this output which is connected to the output of the oscilloscope, just remove it and connect the prop from PSK output to PSK input. You will see the output which is connected, which is the clock generator, which is alternate 1 and 0. That is this waveform you will see, that is, it is for the modulation, output is this for the modulation, and for demodulation output is this, okay, which is applied at the input of the modulator. Okay, by using the this FFT button, okay, if you press this FFT button and by adjusting some function, you can see this the spectrum for the BPSK. Okay, it is the spectrum of BPSK signal. Okay, that's how we will study the experiment number 2, which is the PSK modulation and demodulation. Okay, it is the theoretical circuit, you can see in the block diagram in your lab manual. It is the PSK modulation, the PSK demodulation. It is the theoretical part, which is already on the pan of the PSK modulation and demodulation. It is the for modulation. You will see the output here. Okay, it is the output for demodulator, and it is the spectrum for BPSK signal. So you can see at the center frequency the amplitude is highest, but main remarkable thing is that the bandwidth is FC plus RB. Okay, so it is the BPSK spectrum analysis of the BPSK waveform.